Having had an overview of what Pert is, let us take an example. We are presented with this information. A project consists of 8 activities with the following characteristics. Activity A has no predecessor, it's a starting activity. You recall this from our previous lessons. Has an optimistic time O of 3 days, a most likely time M of 5 days, and most pessimistic time 12 days. Now, when you get to understand what optimistic and pessimistic is, optimistic having a positive outlook uh, and expecting the best outcome, whereas pessimistic is having a negative outlook and very doubtful and expecting a worse possible outcome. So these days are the probable days these activities can get completed. You recall that PET is used for uncertainties where we are not sure about the completion of certain activities, and those activities are part of a project, so it requires that they use the scheduling method PET to schedule those projects. Activity B also is a starting activity and has no predecessors. Is optimistic, most likely, and pessimistic times are given. So the table is complete, and these are the information we would use to solve the problem. 1. We are required to draw the PET network for the project. 2. We have to prepare the activity schedule for the project. And 3. We have to determine the critical path. Let us look at how this will be done. Solution. Let's take the formula of expected time. That is optimistic time plus most likely time times 4, and then plus pessimistic time, all divided by 6. Using the formula for expected time TE, we shall complete the table as shown below. Now, we have a new column stated, which is the expected time. How do we get the values to fill the column for the expected time? The formula, as stated, optimistic time plus 4 times most likely time plus pessimistic time, all divided by 6, is what we would use. So we have to calculate the expected time for all the activities. So we started with activity A. Most optimistic time is 4 plus 4 times 5, which is the most likely time, plus 12, all divided by 6. So that is 36 divided by 6, giving us 6. So the A activity has 6 as its expected time. For activity B, which also has no predecessor, is also a starting activity, has 9 as its most optimistic time, 12 as its most likely time, and that will be multiplied by 4, and 27 as its pessimistic time. When you put that into the formula, it gives you 84 divided by 6, giving us 14. And that is also entered into the table. Then we calculate the expected time for activity C, which is 8 for optimistic, most likely 9 times 4, and then pessimistic 10. The product and addition all divided by 6. So that's really 4 divided by 6 giving us 9. So the formula is used to calculate for the others and the results entered into the table. So this is what the table looks like, and the values of the expected time have been entered accordingly. Let's move on to the next slide to draw the PERT network diagram. So PERT network diagram. We have activity A, activity B. Because activity A and B are starting activities, but activity C is preceded by activity B, D, E, F, G, and H. So we'll draw the linkages, and this is how our PERT network diagram looks like. So as we are very familiar with how the PDM diagram is drawn, I will not belabor the calculation of the values that will be entered into the network diagram. That is to say, forward pass and backward pass and determining the float. I have done that, and the values are entered. So when we look through the network diagram, B has a zero float, C has a zero float, F has zero float, and H has zero float. And that path would be our critical path. We recall that the path with zero floats are critical paths. The paths with different values of floats other than zero are paths that are non-critical, and those activities can be rearranged or moved within the limit of their floats, and that will not affect the completion period of the project. So this is our PERT network diagram. So the critical path is the path with the very thick red arrows as indicated. Total duration is 35 weeks. Critical path is B, C, F, and H. Slide. The activity schedule for the project. The activity schedule is more like the same table, but with early start, early finish, late start, late finish informations. And that has been completed. So the critical path is B, C, F, and H, and though they are indicated in red. The early start, early finish, late start, late finish values have all been entered. So this is how the activity schedule for the project is completed. And the last of the question is for us to find the critical path, which we have found already. The total duration of 35 weeks, and the critical path being the path B, C, F, and H.